Hi guys, what's up? So today we are going to solve the Leetcode day 10 problem, sorry, day 9 problem, and I hope you all are doing fine because there has been a coronavirus thing that is going on. So stay home, stay safe. Let's just jump on to the problem. So, given a positive integer num, write a function that returns true if num is perfect square as false. Okay, so we'll have to check if the given number is a perfect square or not, and we are not allowed to use the built-in squared function. Okay, obviously. So in this case, 16 is a perfect square of 4, or like it has a square root of 4, but 14 doesn't have a perfect square root, so we are going to return false. So I think this kind of problem is a typical case of using a binary search. So what we can do is, like, let me just explain this. So we have our range, which is from low and high. So my number can be, so since this is a positive number, so the value could be 1 as well, and value could be 0 as well. So we'll start our low from 0, and the highest that a number can have is itself. So we'll have to search between these two range, these two numbers, whether the square of any of these number is equal to the given number. So in this case, let's say I first do like from between 0 to 16. So I get my mid value as 8, right? So somewhere here. So now I calculate the square of 8. The square of 8 is 64, which is much higher than 16. So my high will become 8 and my low will be 0, right? So this will be my low. Now I again need to I have my range between 0 to 8. Now I find the mid value, which is 4. Now I basically do the square of 4. The square of 4 is 16, which is equal to the given number. So I can simply return true from here, right? So let's just go through this 14 as well as example. So for 14, I have my 0 as low and my high will be at 14. So this will be low and this will be high, and let's say that, so my mid value will be 7, will be somewhere here. Now the square of 7 is 49. But 49 is much higher than 14, so we'll have our high here and our low will be still at 0, right? So now I calculate the mid value of 7 and 0. So 7 and 0, the mid value will be 3. Now the square of 3 is basically 9, so which is smaller than 14. So my low will be set at 9 and my high will be at 7. So my high will be at 7. So this is my high, right? Now my range is become 7 and 3 and 7. So if I calculate the mid value, it will be 5. Now the square of 5 is 25, which is higher than 14. So my high will become this. So my high will essentially become, like, I can also decrease it, like my high will become 4 and my low will become 3. Now the mid of these two will be 3.5, or I would say 3, and this is smaller, so I'll increase the 3. So now 3 and low and high will become equal, both will be 4, but I have not yet find out my perfect square, so I'll simply return false from here, right? So let's just write code for this and it will become more clear. So we'll have low and high, right? which is 0 and num initially. So while my low is not less than equal to high, I'll calculate my mid equal to low plus high divided by 2, and I'll calculate current square, which is mid into mid. So if my current square is equal to my given number, I'll simply return 2 from here, because I have found that the square root exists. If that is not the case, I'll actually so there are two cases possible. One is that my square is less than number. In that case, my low will become mid plus 1, because now I'll search for the right range, right, from mid to high. And if my current square is greater than, then my high will become mid minus 1, correct? Because now I'll have to search in the left range, and my upper value would be mid minus 1. If after searching through this I could not find the perfect square, I'll simply return false. So let's try to run it. Let's try to submit it. Got accepted. So the time complexity, since we are using binary search, so if we are dividing the range of the search interval into half each time, so it will be log of n, where n is the number, so which is pretty fast. Log of n is pretty better, and space complexity will be constant because we are not using any space, we are just writing an iterative solution here. Okay, thanks guys for watching. We'll see you tomorrow. Don't forget to like and subscribe if you like the video.